All right, this next example, I've been asked to simplify this expression, and in doing so, we're going to achieve that by this idea of expressing numbers as powers of the same base. Well, the bases here are 12, 48, 27, and 16. And if I start to look for sort of highest common factors of these folks here, I'm ignoring the x and the y as the powers at the moment, then obviously 12, there's going to be a relationship between here and here in that factors of 12, if I was just to break that up, is going to be 3 times 4. And if I was to break this up into factors as well and try and reach the same factors, well, we know that 3 times 16 is 48, or if you like, 3 times 4 times 4. So we've got these bases now are common to these two. What about 27? Well, we know that 27 breaks up rather nicely. If I was to break that up into a 3 and a 3 and one more 3 as well. And of course, 16 is going to be 4 and 4. So if we just kept all the bases to be 3s and 4s, because they've got the same base, we can just add or subtract the powers to each other. Well, let's take a look at that taking place and see how this plays out. All right, so first of all, I'm going to turn this into 3s and 4s because we know that if 12 to the power of x, 12x plus y, that's going to be the same as saying 3 to the power of x plus y times 4 to the power of x plus y. In other words, 3 times 4 is 12, and they must have the same powers. That's all. Times 48. Well, 48 is 3 times 4 times 4. Here it is. 3 times 4 times 4. Now I'm going to sneak in the powers here as well. And this is an x minus y. So I've got an x minus y, an x minus y, and an x minus y. There they are. All right, and that's all over. So in other words, 3 4s are 12, and 3 times 4 is 48. I keep the powers the same for each thing. So the 12 was the 3 and the 4, which is x and y. X and y, here it is. And the 48 was x minus y. So 3 times 4, but x minus y, x minus y, x minus y. All right, on the bottom, we've got 27 to the power of x, which must be 3 to the power of x, times 3 to the power of x, times 3 to the power of x, times 16, of course, was 4, times 4. I'm going to leave a bit more space this time because I kind of messed up last time. Okay, here we go. And we have an x plus 2y. We didn't have enough room. Here we go. X plus 2y. That's not too bad. We can kind of see where we're going with that. All right, let's just move things across a bit so I got room to write. Now, of course, we didn't have to write it like this. We could have simplified this considerably. The top bit we can't. We've got 3x plus y. And we've got 4x plus y. But as you're writing this out, you might wanted to have said, we've got times 4, and you've got 2 lots of x minus y. Here we are, x minus y. And that's the same as saying 4 to the x and y times 4 to the x and y. And we know that because when the bases are the same, we can add the powers. We've got 2 lots of x, there they are, and we've got 2 lots of negative y, there they are, so 2 lots of each. All over. Same deal here. This is 3 on the base, but we've got an x and an x and an x is going to be the power of 3x times, now this is a nice one, we've got 4x plus 2y, 4x plus 2y, which is exactly the same as saying 4 with 2 lots of x plus 2y. And there's a slightly simplified version. Now let's combine all these folks as best we can. Now I notice I've got a 3 base here and a 3 base here. So I'm going to have 3x plus y times 3x minus y, which is the same as saying 3 to the power of x plus y plus x minus y. So now I've got that and that dealt with. Then I've got a 4x plus y times 2x plus y. So I'm going to expand that out now. I'm going to say this is going to be times 4 I've got an x plus y, there it is, and I'm going to add it to plus 2 times x is 2x, and 2 times negative y is minus 2y. So there's the top. Let's see if we can do something with the bottom. We kind of can. We'll just leave it as 3 to the 3x, and this is going to be times, and I'm actually going to write this out, 4 to the power of, this is going to be 2x plus 2 times 2 is 4y. So that's where we land right now. Okay, now let's combine all this lot, make it all simple. So we've got an x and an x, so it's going to be 3 to the 2x, and y minus y is 0. Next bit is times, this is going to be 4. Now I've got an x and a 2x is going to be a 3x, so it's going to be 4 to the x and 2x is 3x, and a y minus 2y is minus y. And that's all over. I've got a 3 to the 3x times, and I'm just going to leave this the way it is, 4 2x plus 4y. All right, well, hopefully we got this right so far. If we haven't, we're going to be in deep trouble. All right. Okay, and now we can see I'm now going to, same basis, I'm just going to subtract these powers. Well, 2x minus 3x is just negative 1x. So I could write this as 3 to the negative x, or I just put 3 to the x on the bottom. So I can just rewrite this as, this here becomes 3 to the power of x. Over here we've got, I'm just going to pop this, in fact I'm going to write this on the top. That's going to be 4 to the power, and I've got 3x minus y. And then it's going to be minus the whole of that bottom, minus 2x plus 4y. All right, let's see how that plays out. And that's equal to, now I've got, in fact, I'll rewrite this, it's going to be 4, 3x minus y, and it's going to be minus 2x, and this is going to be minus 4y, minus 4y, all over 3x. Now, does that all work? So I've got a 3x, and I've got a minus 2x. Well, 3x minus 2x is just x. So this is equal to, in fact, I'll write this over here. I'll put an extra little bit up here. So I'm now going to head up to the top of the page here. So I've got a 3x minus a 2x. So I've got a 4 to the power of x. I've got a 4 to the power of x, and a negative y minus 4y is negative 5y, minus 5y. Now, on the bottom, I've simply got a 3 to the power, oh, I got a 3x. It should be 3 to the power of x. Why did I even think about right there? So it's 3 to the power of x. Here we are. So it's 3 to the power of x. And there is my solution.